This video is supported by ImmuDB, the world's fastest immutable database. Hello everybody and welcome back to the Moshik's Mainframe channel. This is Moshik's. Everybody loves MVS 3.8, especially the one that comes with the TK4 distribution. It has so many programming languages that it's easy to use it as an amazing development platform. However, one of the greatest things that happened to our MVS 3.8 community and also VM370 communities over the last, I would say, 6 to 10 years is the introduction of network job entry networking between mainframes. And today we're going to look at how to write amazing applications, and it's very simple to write applications on MVS 3.8 using the possibilities of network job entry networking between mainframes. But before we get there, let's go to the commercial break.
Ladies and gentlemen, IBM presents the 3279 color terminal. Mr. Ruben Singer is at the keyboard. Observe how the color terminal saves your eyes a lot of work. First, a simple listing of sales districts. Districts that have met their quota in yellow. 3 districts fell below quota. And 1 20% over. The same information on a bar graph. Sales trends by product on a pie chart, brimming with color. A quick look at how our theoretical company is doing countrywide. The IBM Color Terminal and Friends. IBM, helping put information to work for people.
And we're back again. So as I was saying, the greatest thing that happened to emulated mainframes such as MVS 3.8 operated mainframes and VM370 operated mainframes is the introduction of network job entry for this 38 years old operating systems. Because once we can network our mainframes together, new possibilities and new horizons open up. And that's why about 1.5 years ago we started a new network called Hnet, which is a bitnet for emulated mainframes and also sometimes non-emulated mainframes, such as my own real iron mainframe, and there's a couple of universities and other companies with their mainframes participating. And we have today, this is not a complete topology, but there is today over 120, 130 mainframes attached to each other. Some are IBM mainframes, such as Linux, some are Linux machines, some are digital equipment mainframes or mini computers, all participating, and you can send messages from one user on one machine to another user on another machine, or even to another user on the same machine, or exchange files and applications between all the participants in the network. And the network is growing nicely. And it is only in the last 6-7 months that we have now network job entry for MVS 3.8. Traditionally, NJE has been accomplished through JES2 on later versions of MVS, such as MVS XA and MVS ESA and OS 390 and ZOS. However, MVS 3.8 was left out in the dust because IBM never gave it a network job entry connector to JES2. And so one of our community's most amazing developers, a gentleman by the name of Bob Polmenter, he went and wrote a whole subsystem for network job entry specifically for MVS 3.8, but it will work also in later versions of this mainframe operating system. And you can easily find it if you go to GitHub and you go find my repository. I can't type today. You will end up here and you will see that there is here NJE 38 MVS. If you go to this repository, you will see the amazing program written by Mr. Bob Polmenter. I'll make it a little bit bigger. By the way, I have some people sometimes writing me that they can't, it's difficult to look at my videos on their phones, and yes, I understand, but when you have a lot of text, such as necessarily when you work with traditional mainframe operating systems, and even with Linux sometimes, you will have a lot of text, and that is meant to be seen on larger screens, such as maybe iPads or laptops or computers or even on TVs. I watch my videos and other videos on my smart TV. So Bob Palmenter went there and he wrote this NJE subsystem for MVS 3.8, which installs without any problems on MVS 3.8, and I've made several videos that I will point to in the description below this video on how to get this installed on your MVS 3.8. The amazing thing, however, is that this is going to be part of the next release of MVS 3.8 TK4. So in update 9, Jürgen Winkelmann has already expressed that he is going to include this subsystem as part of the distribution. So as soon as in the next couple of months update 9 of MVS 3.8 TK4 comes out, there's no need to install anything. Right now you would still have to get here to my repository and download the zip file and then install it. But within just a few months, this is going to be coming pre-installed on every MVS. And the greatest thing that happened, as I mentioned, over the last 10 years is that now we can network our mainframes. We can exchange files. We're writing applications all the time for this new network. And as you may know, BitNet for a while was the largest network before the internet came up. There were many thousands of mainframes all around the world, in Europe, in the US, in the Middle East, in Israel, in Asia, Japan. Even I think 1 or 2 nodes were present in the Soviet Union at the time. So it was a research and academic network, but it was at the time the largest network on Earth before the internet came up. And so when people had this network available, they started to write applications for it. Now the applications that existed back then for the network job entry network, like something like this, but of course it was much larger, are of 3 types. Service applications, so that people could do interesting things with them or get more information, more access to information. Then there were kind of information exchange applications such as chat and then there were games, of course, and then mailing lists. So the 3 applications that existed almost on every major node on BitNet back in the time were the following. The best known one, of course, is Relay Chat, which is the precursor of the IRC chat that we all know, which allowed people on BitNet to exchange messages and to write to each other, and every mainframe had a Relay Chat server going. The second one is also quite well known, is listserv. So major nodes were running a list server so that people could subscribe to mailing lists, and every mainframe would have one specialty or the other, and so people knew where to subscribe to get information and be on mailing lists. And the third one, which is maybe the least well known but the most amazing program of all, is Trickle. Trickle allowed people to request files, and so it was a huge file storage, and people could send messages and get files sent to them automatically. And so since we started Hnet, or our new BitNet implementation between all our mainframes, it has been my goal to start to re-implement those 3 servers, 3 services as programs, as free programs written in Rex, so that people could re-experience again and have the usefulness that comes with these 3 services of Relay Chat, of List Server, and the Trickle file server. So I've already made several videos. In fact, about 1.5 years ago, I wrote the first implementation of Relay Chat, but that was based on an external program running in Go on a server, and that works fine. It's very scalable, and that's all easy and okay. But I wanted to re-implement it again in Rex and run it natively on VM, because Relay Chat was running on VM during the duration of BitNet, and every major mainframe would have a user called Relay, and that was running the Relay program, the Relay Chat program, so that people could either connect to one mainframe on their Relay Chat server on that mainframe and chat there a little bit, or they could connect to another mainframe and chat with the users who were logged into the relay chat on that server. And since it's old network, it doesn't really matter. You can send a chat message to this relay chat server or the other. Later on, these relay chat servers started to federate, which means that and this is where you see the connection with IRC, that if you send a message on one room, on one relay chat server, on one mainframe, it would automatically then forward this message to all the other relay chat servers it knew about on BitNet, so that it didn't matter where you were logging in, as long as you were in room, I don't know, PL1 programming, all the messages that were going on all other relay servers, on all other mainframes would appear wherever you were logged on. And that's what I call federation. And then, so I started to write that again. And as you can see here, I'm logged in here to my real Iron mainframe. And I can show you that I have a user called relay here. And that user is running a Rex program. And so I can talk to that to the user, of course, by saying tell relay stats, and then it will send me, it will answer back that this is the program running inside this service virtual machine and written in Rex, in VM Rex. And it just tells me that right now there's one user, probably me, and the highest number of users today is 2, and it has seen 34,000 messages, 0.27 messages per second. It's been running since 19th of January. The CPU load is 0 right now, and the chat version is 2.6. So I wrote, so I don't have to type each time to tell relay, because it's cumbersome. I wrote a very simple Rex program so that it just forwards whatever I type as an argument to the chat server. So I call it chat. So I do chat system. As you can see here, this is my IBM Z114 answering machine type, and this is all done by the script automatically. And so this is very scalable. It's running nicely. So I can say chat who will tell me who is there. Right now it's only me. Or I can say chat help, and I get the chat message. And of course, this is right now only a very simple implementation of all the commands. Relay chat server during the 80s and real BitNet had dozens of commands. But they're easy to implement, because I'm going to show you right now how this looks, what the software looks like. So if we go here, we're going to have here a repository called, where is it? This one. So the software that is running here right now, you can find it on this GitHub repository, Moshix, my user, and then relay chat. And this is the program that is running right now on this machine. So let's go look at the code. Okay, here it is. So as you can see, it's been going through quite a few iterations, but it's very simple. You have some configuration parameters, such as what is my node name, etc. And then this is the federation I was talking about. Which other mainframes do I want to connect to and exchange with? And here's the code. So what happens here is that there's a function on VM called wake up, which means wake me up whenever I receive a message. And you can see here, let me make this bigger. Wake up when I get a NJE message. And then when the message comes in, it parses the message for who sent it, on what node, because of course users don't have to be on this mainframe. In fact, I have another mainframe running on my ZPDT. If I say tell relay at, well, I don't remember the node name right now, but I could also send chat messages to any other mainframe in the NJE network, because it will answer to anything. So I parse the node, I parse the user, and I extract the message that was sent to me, to the program, and then I start to handle the message. So I say that if it's a who, then it's going to be handled, who's online. Then it's going to go to a function like this, which sends who's online. And I store all the number of all the users who are currently logged on. I had to find out how to store them somehow in an array, and as you know, arrays are not really dynamic in Rex. So what I did is I created a linked list, and then I add linked list, and then each linked list node will point to the next node in the linked list, and this is how we store all the users. So I parse if I want to send people who is currently logged on, as I was showing you here. Then I go through the linked list and I extract all the users that are currently logged on, and then there is an auto log off time if people haven't been active for an amount of minutes that is system administrator configurable. Then it will log those off, and then the ones that are still logged on, it will say who's logged on and the last time they were seen. That's why I extract the current time right now. So, and then it will send to the user that requested it, because I parse here which user or which node sent this request. Then I send it to this user, so you can see here at this node, total online right now, and then I send them who's online. Very simple. And then you can log off users, you can log on users, you can send system statistics, as we just saw here. All kind of, we can help. We have a help menu, which we just saw. This is this one. Very simple. And then when somebody new logs on, all the others are informed that a new user joined. And we have auto logout, and we have loop messaging detection, and many other things. So that it's only about 800, maybe 750 lines of code, but it's very reliable. We've stress tested it with about 150,000 messages recently, and it never went down. So this now can run on anything that is VM, and it will auto detect what version of VM it's running on, and then remove all the functionality that are not available in older versions of VM, such as VM 370, etc. And this has been running fine, and there's many users running this as a service on their own mainframes connected to the Hnet network. Now, of course, the reason for this video is how do we make this available also on MVS, and this is what I'm going to show next, how we took the software and made it also work on any normal MVS 3.8. and my hope is that it's going to be that the relay chat server, which does run now, is going to be shipped as part of MVS 3.8 TK4 update 9 whenever that comes out in the next few months. So, as I was mentioning, we already have all the ingredients to easily create Hnet or Bitnet or NJE services, even on MVS 3.8, because we do have network job entry, which works very reliably. I've been using for about a year, and as I said, I made some videos for this channel, and I will point them in the description below this video. And also, we have quite an amazing Rex implementation for MVS 3.8. I know that some people say, well, MVS always had Rex. Well, no, Rex only came later. MVS 3.8 did not have Rex, and even VM 370 didn't really have Rex, and so that only came much later. And the TK4 that we've had until now doesn't come standard with Rex. However, Mike Grossman and Peter Jacob in Germany have written a Rex or have ported Brex over to TK4, and it runs very, very nicely. I've made a couple of videos about it in the past, and so we're going to use these two components to create the service that we also have very easily implemented on VM. So what I did is I went there and I created here, as you can see, I sent myself, of course, through NJE the original source code that we just looked at here, but that wouldn't run as it is on MVS because it relies on certain VM APIs that I mentioned before, such as the wake up call does not exist on MVS. Okay, so how do we get notified when we get messages from the network? Because we need to be passed those messages to this program, and there is no easy way to do this on MVS. And so I expressed my wish again to Bob Polmenter, and he went out there and he implemented a very similar interface for MVS through his network job entry protocol for MVS, so that now I can get notifications when messages come in. So where does it happen? Here. So here is the part where he wrote an exit. As you know, in MVS parlance, an exit means an API. He wrote me an API call which we call here NJE init, which means I register with network job entry for MVS saying I want to be known as user relay. So if any messages for relay come to me, don't look for them online on TSO. Instead, pass them to me to my program so that I can handle those messages. So I call NJE init. First I initiate it, then I register the user ID here. And then once that happens, I'm now registered with that user. And now I can start listening for messages coming in. So how do I do that? Here, event equals NJE receive. You can see this. This is the part that corresponds to the wake up call on VM. Okay, so if you can see this here, this line 112 corresponds to this line here, 96. So this would be the same thing. Only wake me up when I got a message specifically for my user ID. So when that happens, I then start to do the same thing. I parse the message, I extract the user ID, I extract the node, and I extract the message, and I start to handle it. And the rest of the code, as you can see here, is exactly the same. So once we had that done, it was really just no change at all. And all the rest of the program, the double linked list that I put in here to store the online users and everything else works exactly the same. The scalability is pretty much the same. And I did not have to change anything else other than those lines that deal with the API to get notifications and to send messages. So this works just fine. And as I said, nothing else needed to be changed. And now let's see how to use it. So let's pull up the other terminal I had here. So here's my VM machine, my real iron machine, and of course I can see here my MVS machine. As you can see, this is MVS, and I have here a relay exec running. That's running in as a starter task, so that's running in its own address space. It's not a TSO program running, but it is this very code that we're seeing here. And of course, if I want to see what kind of operating system it is, so just you can see this is OSVS 3.8 with JS2 on an emulated 3081 with NJE version 2.2. This is the program that I installed, which with TK4 update 9 is going to become installed by default by Jürgen. So I can now send a message to say tell the relay at, this machine is called Kix because I'm running the Kix emulator there, and I say help. And now the program here is answering. Now, of course, this is not, as I mentioned, it's not running inside TSO. It's running as its own address space. As you can see here, we just received the log, the syslog of this machine just shows that we got a message from my user here, and that it executed, it passed it on to relay. So now I can say chat, tell relay at log on, and now I will get logged on, and it says you're logged on, and it knows what machine I'm coming from. And that is exactly how relay chat worked on BitNet in the 80s, when there were thousands of mainframes and hundreds of thousands of users in universities around the world talking to each other exactly like that. Obviously it was much slower because there was no TCP transport, so it was all very often was through dial-up lines, so everything was a little bit slower back then than as you can see here, but the experience is pretty much the same. So it doesn't matter now where I'm logging in. I can log in to my MVS machine, or I can log in to any other machine running the relay chat code, which is open source. Everybody can just download it from GitHub and install it within minutes or even seconds and get it to run. And the other features that feature that I then implemented is federation, so that now they can, if I log into one machine and type a message there, it will appear to all other relay chat servers on Hnet, on our NJE network, that are connected in the federation, so that it doesn't really matter where you chat. You can just do it locally if you want, and then all the others will see those messages too. And so very happy that we've done that. And so I thought that for this video, since this is a little bit of a longer program, the relay chat, I will actually go and write another program to show you how easy it is to write your own service, whatever you can come up with. So I wrote something called info. So if I tell info at how kicks, it will come back now with information about this very machine here. Okay, this is the machine that answered now. And by the way, these two machines are at least 10,000 miles apart. This one is in Sweden, this one is in Illinois. So, so you can see here it answers that Herc01 is logged on, which is true because that's me right now logged on this mainframe. And it says, you know, how long the machine has been up and running, and some other information. I can also say tell info stats, and tell, of course, info at how kicks stats, and it will come back and tell me some statistics. Number of requests since this info MVS started, 25. Number of messages sent, 146. System name, machine type, all that kind of stuff. So let's see how to write this program. It's very simple. So once you are connected to another mainframe, and you know our mainframes are connected to each other, the possibilities for applications and things that we could write adventure games, anything, because it's amazing. So let's go look at it. Excuse me. Here's this program here that answered to this. Okay, so as you can see here, it's very little information, configuration parameters that you need to provide. What is my node name? The node name of this machine. Info version doesn't really matter. And then we register with this user ID. We can't register with relay again because that is already another service registered with that. And you can have infinite number of users registered. The resource usage is very, very small. We could have hundreds of this running on an emulated MVS 3.8. So then once we registered, we can go into the loop into a forever loop, where we'll listen for commands or messages being sent by other machines. Once we receive a message, we get a wake up, and then we handle that message. So we go to handle message, and the handle message is this one. So you can see here, and there we say who, just tells me who's online. So this one, tell info at who will come back and tell me who's online, and as far as I know, it's only me right now. Yeah, so you can see here that's only me. And IPL date, then it gives me the IPL date, the stats, and if I don't provide anything, they will just assume that I want full information, like this printout here. So then it's just normal recs. I mean, this is so simple. A 10-year-old could do it easily. So send who, we go through all the MVS control blocks, and I've made videos about this in the past, to go find out of all the address spaces which ones are TSO registered address spaces, and then we extract the user ID from those control blocks, and then we just say who is online. Okay, so this line here was printed here. This is this line, which we go by going to the address space control block, and you know all this chained control blocks, of which we made already many videos in this channel. It's not hard, and there's many manuals that explain how to do it, and then we print out who's online. If we want stats, then we print out this stats, number of users, number of requests, because we track them here in the Rex program, and then we extract the user, the MVS name, system name, and other relevant information, and then we send that. So it's very, very simple, really, and to do that. And this format here, as you can see here, is here. So there's no magic at all. It's dead simple. And this is just, I wrote this maybe in 35 minutes, 40 minutes, just to show you how to write very powerful and simple services for network job entry. And that's why I think this is such an amazing thing. I think that, you know, people, the community, are going to write lots of programs and maybe games and things that I can think of in ELIZA. Very simple to write ELIZA because the code is everywhere and we just have to adapt it for NJE, which is maybe an additional 20-30 lines to write. Very simple stuff and very powerful too, and very stable. It's been running for weeks now, and so now we have, of the three main services, Relay, Chat, Listserv, and Trickle, we got Relay, I think, covered. That works. It's reliable, it's scalable, it's fast, and very simple to install, and multi-platform. You can run on MVS, you can run on VM, you can run on anything of that sort. The second one I have kind of also already done, Listserv. I made a video about it about a year and a half ago, or a year, 2-3 months ago, but I think we can do it better. I did contact Eric Thomas, the person who runs the Listserv company today, the one that is still running today over TCP/IP, and asked him if he was willing to make Listserv, a very early version of Listserv, available for VM, but he refused to do that. That's unfortunate, but it doesn't matter. However, we can easily write that again, just a couple of weeks of work. However, I did contact the author of the third program, Trickle, Bitnet, and where is it? Oh, it's got a T there. Okay, so let's look at this for a second, because this, I think, is actually the most amazing program of all. Trickle was a file forwarding service on Bitnet, obviously. It was created when many sites in Europe only had access to Bitnet on compatible networks and not to the internet. And so they wanted to get files, such as programs, such as text documents, anything. And so this person in Turkey, at the university in Izmir, Turgut Kalfuglu, he was running the TR node at the university, at the Ege University in Izmir, and he wrote Trickle. And you could send a command to Trickle, which was running then on many nodes around the world. It's just like with Relay. You defined a user Trickle, and then you would run the program inside that user that would serve the network at large. And so you could send the program to Trickle a message saying pdget directory file, and so then it would go and get me the file that I needed. So for instance, as an example, pdget ms-dos games matmax.arc, and it would go and get it and send it to me over network job entry. And so people will use this quite a lot, and it was a line of 40,000, as you can see, 40,000 lines in Rex and some assembler. And he got an award of the European Academic Research Networks for this amazing program that he wrote, which saved a lot of bandwidth, because now only few servers had to store all those files. And if a Trickle server didn't have a file that a user requested, it would go and ask other Trickle server if they had it, and if one had it, they would send it and forward it. So it was very, very intelligent software. So I contacted Turgut. I've looked for him, contacted him in Turkey. He's still in Izmir in Turkey, and we are now starting to see if we can resurrect, if I may say so, Trickle again over our Hnet network. He's already connected to the network. If I see here PSTRVM1, that's Turgut running in, that's his mainframe running in Turkey, and as you can see here, he's fully connected, and we're working towards restoring Trickle service for all mainframe users, so that you don't have to go and find files and then upload them through terminal upload or FTP, all that kind of stuff. There's going to be 1 or 2 or 3 very central Trickle servers, maybe the one on my real Iron, because it has the processing power, and it's very stable because it's real IBM iron. And so people can then go and request files, and they don't have to upload or send them to each other by email and make and then convert them from ASCII, all that kind of stuff. So there's going to be a few very central servers out there that will have Trickle running. One more, of course, is going to be the German ERN, which is run by Mike Grossman, and so he has it running here as well. And from I'm sure that he will also going to run a Trickle server. He already has a relay server. It's not on right now for some reason. I think he wants me to fix some little bugs he's found. But so it's going to be a DERN in Germany. Then there's my machine in Europe as well. There's going to be maybe Turgut's server in Turkey, and a couple of central machines here in the US as well. So I think what we got here is amazing. We are recreating the BitNet network with all the central services of Relay, Listserv, and Trickle. And I think that as soon as update 9 will come out, which has network job entry by default in the system, I think we're going to see an explosion of connected mainframes, and I think that the fun is we're only getting started with the fun on MVS and VM370. The possibilities are infinite, and I'm very, very excited to be playing a role in this, because it's so much fun. I mean, I like to sit down and write network applications in Rex here on MVS, because it's so simple, or on VM, it's that simple. And so I thought I'm going to show you all this in this video. If you have any questions how to write your own applications, please either reach out to us in the comments below this video. But I think the Discord channel, of which I will also put the description below this video, is the right place to. There's an Hnet room there where you can ask questions, or of course just connect yourself and then start chatting with all the others who are on our relay chat in the network, which is probably the preferred way for me anyway. Goodbye.